Related rates are a very important application of implicit differentiation. The biggest difference will be that instead of differentiating with respect to x, we will most often be differentiating with respect to t, time. If we do differentiate an equation that has both variables x and y with respect to t, the result will be an equation that has two rates that are related, hence the term related rates. Before we discuss some actual related rate problems, let's do some differentiation with respect to different variables. We know that the derivative of y with respect to x is dy dx. We know that the derivative of u squared with respect to x, ladies and gentlemen, is 2u du dx. We know the derivative of y squared with respect to x is 2y dy dx. Not difficult, I'll review. In like manner, the derivative of y with respect to t is simply dy dt. Instead of with respect to x, with respect to t. The derivative of u squared with respect to t is going to be 2u du dt. The only difference here being the variable what I am differentiating with respect to. The derivative of y squared with respect to t is 2y dy dt. In like manner, the derivative of x with respect to t is dx dt. The derivative of x with respect to x is 1. The derivative of x with respect to t is dx dt. The derivative of x squared with respect to t is 2x dx dt. The derivative of z squared, heavens to Betsy, is 2z dz dt. Recall that dy dx is a rate, specifically the instantaneous rate of change in y with respect to x. That's what dy dx is. dy dx is the slope of a tangent line, but it's also an instantaneous rate of change, the rate that y changes with respect to x at a specific instant. Or one could say the rate that y changes with respect to x. We've said that before. In like manner, dy dt is the rate that y changes with respect to t. And dx dt is the rate that x changes with respect to t, dx dt. So dx dt is the rate that x changes with respect to t. Hello. Differentiate the following equation with respect to t. Here we go. And I'm just going to dt that. The only difference now is, check this out. What is the derivative of 2x cubed with respect to t? Well, it's going to be, and I'm going to dt both sides. Hey, what's the derivative of 8 with respect to t? 0. The derivative of a constant with respect to anything is 0. What's the derivative of 2x? Oh, it's 6x squared dx dt minus 10y dy dt. And what do we have? We have an equation with two rates that are related. This is called a related rates because there's two rates that are related. Example 2, differentiate the following equation with respect to t. Here we go. I'm going to dt the crap out of everything. X squared plus y squared. And I'm going to differentiate 9 with respect to t. Differentiation is a linear operator. I'm going to differentiate the pieces. The derivative of x squared with respect to t is going to be 2x dx dt. The derivative of y squared is 2y dv or dt. Oh, 0. Guess what? I don't solve for dx dt, dy dt. I could, but right now I have an equation with two rates. That's all I know. I have an equation with two rates. Not too bad. Example number 3. Find dx dt, and what we're going to do is we're going to find the numerical value of dx dt for the equation 6x cubed minus y squared equals 5 at the point 1, 1 when dy dt is negative 3. So first of all, let's make sure that the point does indeed work, and we see that 6 1 squared is 6 minus 1 is 5, so the point does. And all I'm doing is checking, make sure that my text is correct, that it's a viable, valid problem. Okay, so I want to find dx dt. I know that dy dt is equal to negative 3. So what am I going to do? I'm going to d dt everything. I write down steps for you, Lee. Thank you, Lee. So what's the derivative of 6x cubed? I believe that's going to be 18x squared dx dt minus 2y dy dt is equal to 0. And so now I want dx dt, and here's a big hint. I'm not going to solve for dx dt until I put all of the numerical values in. So what I'm going to do is I'm going to substitute. I'm going to put 1, 1 in, and I'm going to put negative 3 in for dy dt. So wherever I see an x, I'm going to put a 1. Wherever I see a y, I'm going to put a 1. And where I see the dy dt, I'm going to put a negative 3. So here I go. That's the guy that I end up wanting. Now I have a very simple algebraic equation to solve. So what do I have? I have 18 dx dt. This is going to be 6, so it's going to be negative 6. This is positive 6, subtract 6. That tells me that dx dt is equal to, is it negative 1/3? I'll believe it is. 6 divided by 18, positive divided by negative 4. We do example 4? Okay, so now we're going to do example 4, which is going to be a little bit easier since we have this basic trigonometry stuff going on. I joke, you know, yes, yes, no, no. And so I want dy dt for this equation, x minus sine y is equal to 4 at the point where y is pi over 6 and dx dt is 2. Guess what? The first thing I'm going to do is find the x. Step 1, I'm going to use pre-calculus. Find x when y is equal to pi over 6. That's step 1, because I'm going to need x. I don't think I'm going to need x. I don't think I will. But let's just for giggles find it. So what is x when y is pi over 6? So x is going to be x minus sine of pi over 6 is equal to 4. Sine of pi over 6, what? Woo, 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 woo. 1/2, yay or nay. So this is going to be x minus 1/2 is equal to 4. I believe that tells me that x is equal to 4.5. Did I do the arithmetic correct there? All righty. So now I want to find dy dt if dx dt is equal to 2. So what I'm going to do now, step 2, is I'm going to dt everything. I'm going to dt my equation. What's the derivative of x with respect to t? Dx dt. I almost joke you on that. The derivative of this is going to be, what's the derivative of sine? Cosine. It's going to be cosine of y dy dt, which is equal to 0. And now what do I want? I want dy dt if y is pi over 6 and dy dt is equal to 2. So here I go. Extend my page a little bit. So I want this, I want dx dt is equal to cosine of pi over 6 I got the wrong thing here. I'm sorry. I'm sorry. Sorry. I just messed you up. I apologize. For those of you watching the video, I apologize for you. So put in what you know. You know dx dt is equal to 2. Here was my mistake. I know that cos y is pi over 6, so 2 minus cosine of pi over 6 times dy dt is equal to 0, and this is the guy that I wanted to find. Okay, I thought we wanted dx dt. We didn't. We know dx dt. So now I'm simply going to solve that for dy dt. Cosine of pi over 6. What's cosine of pi over 6? Square root of 3 over 2. So this guy is going to be negative square root of 3 over 2 times dy dt is equal to negative 2, subtracting this 2. Cosine of pi over 6 is square root of 3 over 2. Therefore, dy dt is equal to one over square root of 3. Multiplying both sides by negative 2 over square root of 3. This goes to 1. No, it's wrong. 2 times 2 is 4. This is a positive 4 square root of 3. Okay? B is just find, it's a different, find dx dt when x is 1, or when x is 4 and y is 3. Okay, so what we're going to do now is we're going to do page 194, number 4, and we're going to consider the circle, x squared plus y squared is equal to 25, and we're going to find dy dt if x is 3, y is 4, and dx dt is equal to 8. On your mark, get set, go. Give it a whirl. I'm going to pause the video, so you out there in video land, give this a whirl. Okay, so this, all we're going to need to do for A and B both is to ddt the crap out of it one time. So let's ddt everything one time. The derivative of x squared with respect to t is 2x, dx dt. And the derivative of y squared with respect to t is 2y dy dt, which is equal to 0. So part A we know what dx dt is, and we know what x and y are. We want to find dy dt. So put everything in and solve for dy dt. So I'm going to put, this is going to be 2 times 3. Dx dt is 8 times 8 plus 2 times 4. I don't know dy dt. That's what I want. This is going to be 6 times 4 is 24. This is going to be 8 dy dt is equal to negative 24. Therefore, dy dt is equal to 24 divided by 8 is negative 3. Okay? That's part A. This is part A. You mean it's not 24? Thank you. 6 times 8 is 48. Thank you very much. And then 48 divided by 6 is, this is going to be a negative 48. And 48 divided by 8, heavens to Betsy. What do I want to do? I want to subtract this. Oh, crap, and I'm videoing. Oh, crap. So what is this? 6? This is equal to negative 6, correct? Okay, crap. Okay, so now I'm super fast. And so to do part B, I'm going to put this information in. X, I'm going to put 4 in for x. Bam. I want to know dx dt in this equation. I'm going to put 3 in for y. I know dy dt is negative 2. I know this is all equal to 0. And now I'm going to do some arithmetic. And chances are I'm going to make an arithmetic error. What is this? 2 times 3, I think this is 12, negative 12, so it's going to be positive 12 over here, because I'm going to add 12 to both sides. And so dx dt is equal to 12 over 8, or 3/2. Okay? That a Google